The following questions were taken from the practice tests provided by the College Board. The way to make the most value out of this video is to please solve the practice tests by yourself first. We'll be solving these questions via estimation. Now, if you wanted to see how to find the exact solution of the questions, please check out my other video linked in the description below. Let's get started. For this question, we were given the speed of an object as 12 centimeters per second, and we're told to find the time it takes for the object to travel 108 centimeters. So the first thing that we want to do is to check the units. The distance is given in centimeters for both the speed and the value that was given. The time was also seconds for the speed, and also we're asked to find the time in seconds. So we don't have to worry about unit conversion. Now, if you wanted to solve this via estimation, you would think, okay, if I'm traveling 10 centimeters per 1 second, how long would it take me to travel 100 centimeters? Well, that would be 10 seconds. Which would lead us to choice A. For this question, we're asked to find a percentage. The total is given. We have a total of 900,000 beads, of which 828,000 are silver. We're asked what proportion, what percentage of the beads are silver. Well, 828,000 is almost the entirety of 900,000. So we expect our number, our percentage, to be a little over 90%, which would lead us to choice D. This is another question that involves keeping a proportion. We're told that the ratio of the length to width of a rectangle is 35 to 10. And we're told that the width is increased by 7, so it will become 17, 10 plus 7. And we're asked to save the proportion, so we want the equal ratio, and to find what would the length be. Of course, we can solve this via cross multiplication, or we can take a second and think about it. Since we're preserving the proportion, if the denominator is increased, the numerator needs to increase as well. So choices A and C are out right away. Now, if 10 is increased to 17, that means that it almost doubled. So we want to almost double 35, and that means to add a number that's slightly less than 35, which would lead us to choice B. This question involves an isosceles right triangle, the 45, 45, 90-degree triangle, which I hope you have memorized by now. The digital SAT does give you the formula, but it's best to have these memorized. In this video, though, we're going to solve it by our intuition and some estimation. So we're told we have an isosceles right triangle where the hypotenuse is 58, and we're asked to find the perimeter of this triangle. Let's look at the choices very quickly. We have 29 times square root 2 as choice A. Of course, you can use your calculator, but in the spirit of solving this via estimation, we're just going to go ahead and use estimation. 29 is about 30, and square root 2 is typically approximated by 1.4, but for here, we're going to approximate it by 1/2, or 3 over 2. So choice A is 30 times 3 over 2, which would be 15 times 3. So choice A is almost 45. Now, if one side of our triangle is 58, our perimeter of the triangle cannot be 45. So that gets ruled out. Let's think of the upper limit of this perimeter. by definition, hypotenuse is the longer side of a triangle. So the other sides must be shorter than 58. So the upper limit and upper limit of the perimeter would be if all sides were equal to the hypotenuse. The upper limit would be 58 plus 58 plus 58, or 58 plus 116. Now, if you look at choice D, we have 58 plus 116 times square root 2, which is even bigger than our upper limit. So that choice gets ruled out as well. Now let's look at choice B. That's 58 times square root 2. 58 times square root 2. Let's approximate that. 58 is nearly 60, and square root 2 is nearly 3/2. So that would give us 90. If the perimeter is 90, and one side is approximately 60, that means the other two sides are 15, which is a quarter of our hypotenuse. Which, if we look at it, we cannot shape a triangle with these numbers. So choice B is also ruled out, which would lead us to choice C. This question involves proportion and extrapolating the results from a smaller sample size to a bigger sample size. We're asked to find out by how much would Angel win in the larger sample size. There are different ways of solving this, but one way is to find out by how much does Angel win in the poll that's given. That would be 483 minus 320, which is 163, which was given as choice A as one trap choice. 163 is by how much Angel wins in the smaller size, sample size, but the question's asking by how much would she win when the total voters is 6,424. So if she wins by 163 when the total is 803, we need to find by how much she's going to win when the total is 6,424. Now, of course, you could use your calculator and use cross multiplication, but since we're going to be solving this as an engineer, we're going to see, okay, in order to go from 800 to 6,424, we multiplied the denominator by, say, an 8. And so in order to keep the proportion, we want to multiply the numerator by 8 as well. Now, we could estimate the 163 either as 150 or 200. 200 times 8 is 1,600, which would lead us to choice B. We're given a linear equation and we're asked to find out by how much would the y, our output, or here our f increase when our x is increased by 2.1. There's different ways to solving this, and if you wanted to solve it exactly, please check out the video linked in the description below. But for now, let's solve it with estimation and a little bit of algebra. If we increase x by 2.1, that means to replace x with x plus 2.1. So let's see how that would change our equation. In that case, we will get f of x equals 9/5 x plus 2.1 minus 273.15 plus 32. Now, let's do a little bit of algebra. We need to distribute the 9/5 onto each element of this parentheses. Now, the only difference is the plus 2.1. So that's the only thing that we're going to focus on here. So the only difference has been that our f of x has been increased by 9/5 times 2.1. 9/5 is about 10 over 5, which is 2, and 2.1 is about 2. So basically, we're increasing f by about 2 times 2, which is 4, which would lead us to choice A. This question involves unit conversion. We're given an area in square yards, and we're asked to find it in square miles. Please forgive me, but the square yards, I will see that as 12 million square yards. And square yards is yards to the power 2. Now, in order to convert this to miles, you want to think, since you want to cross out the yards on top, you want to multiply this by a conversion factor such that yards is at the bottom, so they get canceled out, and miles is on top. Now, we're going to put in the numbers. 1 mile is 1760 yards, which I would put as 2,000 yards since we're doing this via estimation. Now, let's look at our units. 1 yard from the bottom will cancel out 1 yard on the top. We still need to multiply this by another conversion factor to completely convert this to miles squared. So we'll multiply it by 1 mile on top and 2,000 yards at the bottom. So now the yards get completely canceled out and we're left with miles squared. So if we wanted to calculate the answer quickly, 12 million over 2,000, this part will give us 6,000. And divide that by another 2,000, we'll get 3. So that will lead us to choice B. This question involves converting radians to degrees. We could use proportion, but a quicker way is to replace pi by 180 degrees whenever you want to do this kind of conversion. So angle R is 2/3 instead of pi, 180 degrees. Now 180 divided by 3, that's 60. So angle R is 120 degrees. Angle T is 5/12 pi bigger than angle R. So let's find what 5/12 pi is. That would be 5/12 times 180. Now 5/12 is about 6 over 12, which is 1/2. So this is about 1/2 times 180, which is 90 degrees. So T is approximately 120 plus 90, which is 210, which would lead us to choice C. This is another percentage question. Now, of course, we could use the percentage equation to solve this question, but I would suggest to just think about it intuitively. Here we're asked what percentage of 300 is 75. Well, what is 50% or half of 300? That's 150. We're looking for 75, so of course, we'll have a smaller percentage than 50. If you look at the choices, that would lead you to choice A. Alternatively, you could think 25% is a quarter, and a quarter of 300 is indeed 75. This is one of my favorite questions from the practice tests, because the data points were not given, but we're still asked a question about the data sets. So we have to use our intuition and understanding of graphs to approach this problem. We're told that we have 2 data sets, and they have the same number of data points. There's only 23 in each of these data sets. We're also told that each of these data points is an integer, and that for the first bar, for example, when it's between 20 and 30, our minimum value could be 20, and the maximum data point could be 29. That means the first bar could either have points on one extreme, 20, 20, and 20, And on the other extreme, could be holding 29, 29, and 29. Now let's look at data set B's first three numbers, the smallest numbers. They could either be 10, 10, or 10, or 19, 19, 19. Now, we want to minimize the difference between these data sets. So that would happen when data set A is 3 20s, data set B is 3 19s. And therefore, the difference would be 3. Now, let's look at the second bar. The second bar is between 30 and 40 for data set A, which means that our values on one extreme could be 30, and on the other extreme could be 39. How many values does this bar contain? Well, that's told from the height. The height is 4, saying that it holds only 4 data points. So on one extreme, this could be 30, 30, 30, and 30, or 39, 39, 39, and 39. Similarly, for the second bar of data set B, its height is 4. So we have 4 data points. And on one extreme, they could either be 20, 20, 20, and 20. And on the maximum, they could be 29, 29, 29, and 29. Now we're told to minimize the difference. That would happen when we have all 30s for data set A and all 29s for data set B. The difference for the second bar would be 4. Now we see a pattern happening. For the third bar, the height is 7, and data set A is between 40 and 50. And again, for data set B, the height is 7, and the bar is between 30 and 40. So it's the same pattern. That means the minimum difference between these two would be 7. Similarly, for the fourth bar, the minimum difference would be 9. Now let's add up all of these numbers, 3 plus 4 plus 7 plus 9. That would give us 23. Now the question wasn't asking for the smallest possible difference between these data sets. It was asking about the smallest possible difference of the means of these two data sets. Because these two data sets have the same number of data points, we could ignore that at the moment, but now we have to bring that back in. So if the smallest difference between these two data sets is 23, the smallest difference between their means would be 23 over 23, which is 1, which is choice B. Now, do you see the trap choice here? That would be choice D. So had you not read the question carefully and noticed that they're asking about the difference of means and not difference of data points, you may have chosen choice D. So as always, please read the questions very carefully. For this question, we're asked to find the amount of fuel that's burnt within the given time. Now, if we quickly check the units of the mass are kilograms and the units for the time is seconds, so we don't have to worry about the units. We need to find how much of the fuel was actually burnt within the given time. So that would be the difference between the initial and the final that's given. And we're going to divide that by the time, 21 seconds. Now, this is one of the simpler questions on the practice test, but the reason that I put it here is that I wanted to bring to your attention that if you were to use your calculator, you would have needed to put a parenthesis between these numbers. Otherwise, your answer would be off by orders of magnitude. And it's very easy to forget that during a test, which is why I would say solve these questions with estimation. So if we initially started with 467,000, I would estimate that as 460,000. And the second value I would estimate as 360,000. So I can quickly do that in my head. That's 100,000 kilograms within, I would say, 20 seconds. Now, that would be 5,000. So our answer is going to be around 5,000, which would lead us to choice A. This question involves density. Now, density is mass per volume, but let's say you forgot that formula and you still wanted to get this answer correctly. Let's look at the units. We're given 807 kilograms per cubic meters. Now we're going to reverse engineer our way from kilograms per meters cubed to kilograms. What we want then is to multiply this number by a factor such that we have meters on top. So what we can do is multiply this by 0.9 meters. Now what will happen here? The meters on top will cancel out one of the meters at the bottom, and at the bottom will be left with meters squared. Now we can do this one more time, multiply it by 0.9 meters, and now the second meters will cancel out another meters in the denominator, and we'll be left with 1 meters in the denominator. So let's go ahead and multiply this one more time by 0.9 meters. And now the final meters on top will cancel out the last meters in the denominator. And we'll be left with the units kilograms, which is what we were looking for. Basically, we multiply density with the volume of this cube. Okay, we could use our calculator here, but in the spirit of estimation, let's just go ahead and estimate this answer. 807 times 0.9 is like 800 times 0.9. So that would be 720. 720 is about 700 times 0.9. That would be 630. And that's about 600 times 0.9. That would be 540. Which will lead us to choice A. As you continue to practice through more questions, I invite you to first ask yourself whether a question can be solved by estimation or not. Estimation can help you save time, it can safeguard you against silly errors, and it's a nifty tool to have under your belt. You can use it outside the classroom too. Say, if you wanted to quickly calculate the price of an item that's discounted, or perhaps during negotiation meetings with your investors for your next great idea. Where else do you see yourself using estimation? Let me know in the comments below, and until the next video, click like and subscribe.